Good morning, everybody. My name is Mike Cappuccio, and today I want to thank everybody for joining me for the Clean Heat webinar that we're doing for the Massachusetts area and the New York area for Jones Services and NETR. So I'm going to advance to the first slide on this and ask everybody to just direct questions to the chat. We have multiple people from both companies on from the New York area and the Boston area that can answer questions on the chat. You will be muted throughout the seminar. And then again, like I said, it's just direct questions to the chat. So we're going to get started. This is about a 45-minute seminar. I'm going to go through this as quick as I can. So again, if you have questions, direct them to the chat. So like I said, we are working in the New York area and the Boston area on clean heating for your home. Some of the things that are going on in the New York area and the Boston area. And so we're going to move forward with that. So a greener and cleaner way to heat your home. I mean, obviously, when we look on the left here and we see how things are being done and what we're advancing to now is, solar and wind power and everything of people being able to generate power like that now and put that into our homes to keep our homes cleaner and greener. So we're going to talk about ways to do that. But first thing is, when we look at the United States and how they do things today, they're basically way behind on air source heat pumps and how people heat their homes. If we look around the world today, you can see there's drastic differences. 8% of homes are heated by air source heat pumps in the United States. We're really trying to change that by 2030. So there are a lot of programs going on that I want to make people aware of as to why and what's happening. So when we look at how we use energy in our homes today, 45% of our energy is used on space heating, 18% of it on water. You'd be surprised that not as much of it is used in cooling. So when we look around and how we do things and how the past was done with air source heat pumps, I mean, I've been in the air source heat pump industry now for over 35 years. And I've seen how this has all evolved over the years and what's changed.
It just says E for Ellen DeMer.
So we look at the one-on-one system on the left-hand side here. This is when we first got into this 25 years ago. These were basically air source heat pumps were being used as niche applications. They were a one-to-one system. What do I mean by that? There was There was one indoor unit and one outdoor unit. So basically, you could only have one condenser outside and one indoor unit inside. When we look now over to the right-hand side, there wasn't as much product awareness, but when we look at now, when we look at this home here, we're basically doing what's called whole home applications. There's a lot of dominant product awareness. Everything is multi-zone. You can do ductwork with systems now. Everything is not ductless with a wall unit. There are units that you can swap out with ductwork on them. And basically what you're doing is you're zoning out your home. And the outdoor condenser sits outside here. So we're taking parts of your home and rooms of your home and being able to let you use those at different temperatures and being able to turn zones off in your home for energy efficiency. It's almost like, if you came into your home and you had a light switch at your front door and you turned it on and every single light came on in your home. You just don't do that because it's not energy efficient. We turn lights off and on in our home because things are zoned in our home. I always used to say to people, you have 5 or 6 burners on your stove. You don't turn on all 6 burners to boil 1 pot of water. So we're kind of doing the same thing here, in what we're doing with our homes with zoning them out. So when we look at electrical use in our homes, 50% of our electrical use in our homes is being driven by HVAC through heating and air conditioning. So it's a pretty substantial amount of electric use that we're using into our homes right now. So we want to look at how we can take this and put this to a greener way to heat our homes. So air source heat pumps Obviously, we know they're greener and they're cleaner, and we have spots of where we're trying to get to by trying to eliminate the carbon in the air. So I want to talk a little bit about a basic refrigeration cycle and how things work. What you have with an air source heat pump is you have a compressor or a condensing unit that sits outside, and there's an outdoor coil. Everything in blue right now is the cold side, and everything in red is the red side. So basically, it's a reverse cycle from an air conditioner when an air conditioner in the summertime, you have cold air coming out of here. In the wintertime, you have warm air coming out of here. So what there is a valve inside the unit that switches this over from heating to cooling back and forth. So when you do purchase an air source heat pump, you do get cooling as well. So we look at this from an air conditioning and a cooling side. Air conditioning and heating side. So what are the biggest differences between a standard air source heat pump and a ductless air source heat pump, or an inverter-driven air source heat pump is what I'm going to call it? We have two different types of compressors in the units. Okay, so basically what we have here is a standard air conditioning compressor. All right, this would be a central air conditioning system in your home, or an older style heat pump that you had in your home. And basically these come on and off and just turn on and off on a call for demand of heating or cooling. They all run at 60 hertz. We have different hertz here on the right that you can notice. And basically what it does is the temperature pulls down, turns on, pulls down, shuts off, warms up, turns on, turns off, turns on, turns off. And you get a lot of parts of your home if you have one thermostat in one area where you have hot spots, cold spots in your house, because nothing is zoned. It's one big thermostat, and it's an on and off system. The highest current draw is this 60 hertz when the machine comes on and calls. I don't know if you've ever seen a window air conditioner and all of a sudden your lights dim in your home. The reason why the lights are dimming is that's because it's the hard startup right there of everything that's going on. So I want to talk about an inverter-driven compressor and what an inverter-driven compressor is, because all air source heat pumps from Mitsubishi Electric or any of the manufacturers that are selling inverter-driven heat pumps right now, the biggest difference is they start up at a very, very low current. If you look, and we look at the 0 hertz right here, they basically start at 0 and they ramp up. It's almost like an accelerator in your car. It speeds up and slows down the compressor. It doesn't turn on and turn off. And as it speeds up, it brings the temperature down quicker or brings the temperature up quicker, depending on if you're heating or cooling. And as it reaches the set point of the room, you can see what happens. The inverter starts to slow the compressor down and brings it down to 30 hertz. All right, so we're not running at 60 hertz, we're running at 30 or below. And we basically slow down the indoor fan on the unit, and we run at a nice fine line of temperature. We don't do what I showed you prior. We're not doing the on and off. We're speeding up and slowing down with temperature, and we're decreasing the amount of current used on the compressor. That's what brings our comfort and our efficiency. So I want to talk to you a little bit now about a heating season and how many hours of heating below certain temperatures and above certain temperatures. I have two slides. First one is the Boston heating season that we took from the previous year. And when you look at this, this is the amount of hours in the year, okay, and the amount of the temperature of where we were and the amount of hours. So let's see, at minus 10 degrees, we had 10 hours. At 0 degrees, we had 36 hours. 10 degrees, we had 342 hours. And these are averages between the two. But when you really look, I mean, from 10 to 40 degrees, and when you really look at the 30-degree mark, a lot of our hours are being spent in that 30-degree mark. And this is where air source heat pumps are super, super efficient within these temperature ranges right here, when you start looking at these two temperature ranges. Again, when you look at 60 degrees, 70 degrees, and you look at the air conditioning hours, I mean, we really didn't have a lot of hours over 90 degrees last year. So that's the Boston area, but I want you to keep these hours in mind because you're going to use those in a second, okay? Hudson Valley, same thing. Here's some of the hours here, some of the cooling and heating hours. Again, bulk of the hours are spent between 20 and, 17 degrees, 40 degrees to 20 degrees in here. This is nighttime. You got to remember, this is usually nighttime when the sun goes down. So how do we look at heat pumps versus fossil fuels in the cost? All right. We look at these at cost per million BTUs. All right. So we look at electric resistance heat at certain cost. These are basic costs of what we put together. So it costs you around $52 to $53 to create 1 million BTUs out of electric resistance heat. We all know that electric resistance heat is very high. Oil heating has gone up. This slide is probably about 6 months old, so I think this is probably more like $35 per million BTU right now. Propane is probably pretty similar to propane right in here. And when we look at gas, I'm just going to slide over here to the right at $15. Gas, we all know, is going up in price too. So when we look at these things here now, these red ones that say COP2, COP3, 3.5, and 4, this is how we rate our heat pumps. We rate our heat pumps on cost per million BTU by the coefficient of power. And the reason why we have to do that is because they speed up and slow down. And where are they most efficient? What temperature? When we're at a lower temperature, yes, they are a little less efficient because they're running at the 2. They're running around the coefficient of power at around the number 2. When we're up around 47 degrees to 45 degrees, we're running at around $13 to $14 here. Gas is very steady because it doesn't vary. It's a cost per million BTU at that point. So I want you to keep in mind these COPs, because when we look at the ratings of heat pumps and how they are rated, they're rated at different temperatures. Now, most manufacturers have a rating at -5 degrees, 17 degrees, and 47 degrees. And that's when they're going to show you the efficiency of the heat pump. So there's a lot of manufacturers that have heat pumps out there that can provide the amount of BTUs that the system will operate at 47 degrees and 35 degrees. When you start to get down below certain temperatures is when the heat pumps lose efficiency. There's a lot of myths about heat pumps back in the 80s, and when they built a lot of condominiums back then from 80 to 90, and they put heat pumps in, and you would hear somebody say to you, a heat pump costs a ton of money to operate. Well, that's kind of a myth in today's world. All right, those differences have changed, and I want to show you what has changed with that. So at 47 degrees, a conventional heat pump had 100% of the capacity. It would, if it was rated at 36,000 BTUs, it would give you 36,000 BTUs at those temperatures. But now we have a lot of different manufacturers that are producing what's called hyperheat. LG has what's called red heating. There's a couple different manufacturers that have different acronyms for what they call their low heating systems. So we're going to talk about that in a minute. But when we drop down to 23 degrees with our Mitsubishi products that we basically sell a lot of, at 23 degrees, a conventional heat pump will give you about 60% of the capacity. With a hyperheat system, you'll get 100% of the capacity of the heat pump at 23 degrees. So that means, okay, at 23, my heat pump from Mitsubishi Electric, my inverter-driven heat pump, is going to give me that 36 or 40,000 BTUs at that temperature. A conventional heat pump will not give that to you. When you look at 17 degrees, you're at about 60% of the capacity. When you get down to 5 degrees, a basic heat pump will not give you the capacity. You're at 30% of the capacity. We're still at 100% of capacity, giving you what you need to heat your home at that time. So at -13 degrees, which we really don't get a lot of, you're still at 76% of the capacity. And we do have heat pumps that are 100% now at -13, but they're very limited. They're only in about 4 or 5 models. All right, we don't have that throughout the line right now, but I do see that coming. Okay, so a conventional heat pump at, minus 13, you're not going to get any capacity out of it. It's just not going to work. And you would now need to put on backup electric heat. When we look at those heat pumps, why did they cost us a lot of money? Well, basically they had an electric resistance heater in the ductwork that would come on below 20 degrees. And basically it was like it is putting a toaster into your ductwork and just leaving it on all day long and just running electric heat. That's costing you a lot of money. If we look back at that slide, at that $53 per cost of million BTUs, there's your cost. Most hyperheat systems do not have backup electric heat in them. You can have backup electric heat put in them, but I don't think you would ever use it on cold days. Very, very rarely. So how does hyperheat work? How do these systems work? When the outdoor temperature drops, the compressor speed increases, the compressor gets hot, we add refrigerant to the compressor, and then we take that heat and we use it inside of your home at that point. So we're heating your home with basically the speed from the compressor and the outdoor air that's coming over the refrigerant and using it inside of the home. So when we look at heat pumps here, and we're looking at purchasing a heat pump, there's some things you need to know of just acronyms. You see a lot of these acronyms out there when you go to buy a washer, a dryer, a refrigerator, an air conditioner, whatever, but sometimes you really just don't know what they mean. But the SEER is the SEER rating, okay? And if it's one thing we just get off of this slide, I just want you to know that higher is always better, all right? So when we look at the SEER rating, cooling output during a typical cooling season, divided by the energy input, all right? The higher the SEER number, the more efficient it is, okay? So a basic SEER rating right now that you have to have in the United States is 13 SEER. The manufacturers cannot make anything less than 13 SEER. And same thing with the heat pump. We're seeing that inverter-driven heat pumps from hyperheating systems or basic air source heat pumps, we're seeing them as high as 30, some as high as 40 with different manufacturers. So, don't get caught in the myth of, a 13 SEER heat pump is cheaper, it's less money. Well, there's a reason why it's less money. It is going to cost you more to operate. So you have to be very, 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 very aware of the SEER rating. What is the SEER rating of this system? Oh, I'm sorry, let me go back to the slide. The energy efficiency ratio. This is what's called the EER. All right, it's the same as SEER, but measured at a given opportunity, typically around 95 degrees and 80 return air temperature coming into the room. Again, EER numbers, the higher the better. These are acronyms that you need to know when you're looking at things. All right, the HSPF. This is what is involved in the heating side. When you start looking at the heating side of these systems, again, the higher the number, the better. It's the ratio of heat energy delivered versus the energy supplied. It's a very, very important number with HSP because you can have certain heat pumps with a low EER and a low SEER. Again, going to be less to purchase, but when you purchase it, just be prepared. It's going to cost you more to operate, okay? So now the COP, this is the coefficient of power that I just showed you earlier. And this is the ratio of heat supplied or removed by a system divided by the electrical energy supplied at a fixed state. This is the COP where the manufacturer rates their unit at certain temperatures. Okay, so this is the higher the COP at certain lower temperatures. Example, 5 degrees, the COP number, and when you look at different manufacturers or different units of different things that you're buying, the higher the COP, the better, the less it's going to cost to operate. Excuse me 1 second. So when we look at average COP, okay, that we were talking about, there's certain ways that this runs at. Again, the electric resistance heat, I want to just point this one first. It's 1 in and it's 1 out. Boilers, when we start looking at boilers, 0.96, direct heat, 0.82, furnaces, 98%, 0.98. When you look at a standard heat pump, and there's a lot of different manufacturers out there now that sell standard heat pumps that claim they heat at low temperatures. But when you go look at the COP at these low temperatures, it's very low, okay? When you look at a typical 4 or 5 zone heat pump from mini split manufacturers, You're going to see they're around 3.7 at 47 degrees. This is going to probably be about 1.8 at 47 degrees. So you got to be aware of the coefficient of powers for the existing equipment. I'm going to move now into a little bit about the equipment and different ways of different things and what they are. But one of the things I want to make you aware of is just common decibels. And you're probably saying, why, why are we talking about sound? But I want you to know of the sound of what these would produce inside of your home. So when you look at a lawnmower that's typically 90 decibels, a blow dryer 80, normal conversations about 50, a human whisper is 13 decibels. When you look at a GL12, this is a wall unit right here, I'm going to call it. This is a basic wall unit from Mitsubishi Electric. This is a floor mounted unit from Mitsubishi Electric over here. And when you look at the decibels, there's different decibels because this is different fan speed, low, medium, medium, low, whatever these, different fan speeds are. But the highest fan speed of that will produce 45 decibels, which is about a normal conversation. And then, looking at 19, that's very, very low. That's less than a human whisper. You'd probably never even hear that running in the room. Same thing with the KJ12. That's a floor mount unit. You can look at the decibels of that with the different fan speeds. And when you look at a typical window unit, it's a 63 decibel sound rating. So it's kind of between a noisy restaurant or a vacuum cleaner and a normal conversation. If anyone's run window air conditioners in their house, you can kind of tell how loud they are. That's usually the first thing we hear from someone when we go into a home and we're looking at doing an air conditioning application. They always say, what I don't like about my home with window air conditioners is just so loud. I can't hear anything. So I'm going to move to the next slide. And we're going to talk a little bit about indoor units, what different models and what's available for different types of homes with the Mitsubishi products that we're talking about today. So we have what's called typical wall units that I think everyone has seen. This is an FH model wall unit now. And you can see right down here, this is the most complex and most high efficiency indoor wall unit right here. It's got a 2-fan system right here. There's 1 fan on the right, 1 fan on the left. Dual vanes as far as directing air. You can see right here where my cursor is on the bottom of this, there's an IC sensor that scans the room and looks for infrared temperatures, hot spots, cold spots, people in the room. Very smart indoor unit. Will set back temperature automatically if need be. Floor mount units, these can go down low. We've used these in a lot of applications to replace radiators in homes for full source of heat. Heat comes out here. Actually goes back in here. One vane directs the cold air back in and the warm air comes out the top, will rise into the room, can be recessed into the wall. This is a ceiling recessed unit. This black pot you will not see. This will go up into the ceiling. And this is what sits flush on the ceiling. This is called the MLZ model. Has a one-way blow right here. The air comes out right here, return air comes in. Ceiling cassette is 2x2. Goes into a 2x2 hole. Most will need to be reframed and air comes out in 4 different spots. I just want to mention one thing. This can go between bar joists, between studs. This is 14 inches, typical 16 on center that will go right in. The 2 ducted units, okay, that you can put ductwork on. This is our low static model. The SEZ unit, this can be used in a master bedroom and a bathroom. Can't put a lot of ductwork on it. Can fit in a very small area. This is about 8 inches from top to bottom. Can go in a closet area, places like that. And this is what pretty much replaces, sometimes we use these to replace furnaces. We replace existing air conditioning systems. If we have a person that has air conditioning and wants to put an air source heat pump into their home for heating, might already have heating in the home, might be using this as supplemental heat, but this replaces standard air handlers in homes and comes up to 36,000 BTUs in the M series. Used with a wall-mounted thermostat. This slide's a little bit old. The newer thermostat I'll show you in a minute, but the thermostat is wireless. It does not have wires between the indoor and outdoor. It operates through a sensor that is tied to both. And that can be used on pretty much any one of these controls, or you can use handheld remote controls on some of the models as well. Any questions on that, direct it to the chat, please. There's multiple people on that can answer those questions. So let's look at what can come in, when we talked about the one-to-one standard heating zones, because we have different types of heat pumps. We have what's called the standard heat pump that will heat down to roughly around 17 degrees to 20 degrees at a full source of heat. Anything below that, we're not going to get the capacity out of it. We would need to move to a different model. But these can be run one-to-one, one outdoor unit, one indoor unit. Again, comes in different indoor units. You can put a ducted unit, a floor mount unit, a ceiling cassette, a wall mount unit, a ducted unit can go with that, and it can go on to that. So now we move to the hyperheat system. This can be used on one as well. This will heat down to -5 degrees. Okay, there's the new thermostat I was just talking about. It's basically like a T10 Honeywell thermostat. Anything you're going to see in the Mitsubishi models that heat at low temperatures are always going to have this red logo on it that say HI2. That designates hyperheat. That's going to tell you that it is going to heat at a low temperature. Can be used in a wall mount unit or a ducted unit. Comes in many different varieties. There are different indoor units you can use as well with this. They're just not on the slide. Can also be operated by the Kumu cloud system that I'll get into in a minute. And there's multi-port systems. Okay, this is a multi-port system, standard heat with no branch box. I'm going to get into what a branch box is in a minute, but you can do up to 5 indoor units off of one condenser with this in your home, and you don't have to have 5 wall units. You could have any type of different indoor unit that you would want to go with that. This is available in a 5-zone unit up to 42,000 BTUs of heating and cooling. This is our branch box system. These go up to 8 zones, and these are what we call a branch box. All right, these are about roughly 20 inches long, 7 to 8 inches high, maybe about a foot back, 12 inches. And these usually get mounted in the basement or in the attic or in the garage. And the pipes from the indoor units would run to a branch box, and then the branch box would have piping that run to the outdoor unit that sits outside. This comes in all the way up to 60,000 BTUs. All right, so this goes up to 60,000 BTUs, which is 5 tons, which is a lot of heat, provides around 57,000 BTUs, I think at 17 degrees. And you'll see this has multiple different indoor units. As far as what you can do, I've got a ducted unit here, a floor mount, wall mount, and then all wall mounts. Many different combinations of how you can put this together. It's what fits in your home and how it's going to work. So over here, next slide, we have the HI2 unit. Again, same thing with a branch box. It's up to hyperheat and how it goes together. So this will heat at the low temperatures. How are the indoor units controlled? They're either controlled by a wall unit, by a basic handheld remote. This is our basic handheld remote control that can be used on everything. And when you get into the more deluxe units, let me just flip back for 1 second. The only thing is with this is a 24-hour timer, okay? It can't do 7-day programmable. It's our basic handheld remote. This remote, you'll see, I have many YouTube videos on this remote if you wanted to go see what I have on YouTube on it. But this basically will do a 7-day timer right here. A little more advanced remote control. You get this with the higher efficiency indoor units. So you do get the programming with that. And again, you can use the MHK2 controller like I showed you earlier on ducted units, wall mount units, floor mount units, has red link capability. This is the sensor that goes in the indoor unit, and then these two just link up together and get used together. If you're doing an air handler or a wall unit, you can use anybody's thermostat with it. Like if you had an Ecobee or a Nest or something like that, you wanted to use it, there is an interface that we can put into the unit. It would need a 24-volt transformer. You do lose some of the settings though on some of the units. It's basically, a lot of it's used on the ducted units, but you can use it on a wall unit as well. Not really recommended. I would rather see you use this control, which is made by Mitsubishi. This is their Kumu Cloud. Okay, which is basically a little white box that gets plugged into the indoor unit, works with Alexa as well. And then we set everything up all of the indoor units get set up onto your phone or to your iPad or whatever wireless device. This is not, can't be put on your computer. It's an app-based system, okay? But it does allow you, if you look here, it does give you all your modes. It gives you your vent, your speed, your auto. Sometimes you'll lose some of these vent swings and the fan speeds when you put on a standard thermostat. We can integrate these into a boiler, okay? So what we do with integrated controls is basically at a certain outdoor temperature, let's say it's 30 degrees for sake of discussion for the slide. First stage of heat would be the heat pumps in the home, and then possibly below 30 degrees would be the boiler. All right, so that would be your backup heater if you wanted to do that. A lot of integrated controls going on in the Boston area. New York area has some of them too as well, but you can integrate this with your system. The way we integrate it, there's a couple different ways. Mitsubishi Electric has a Kumu Cloud station that we would put in near your boiler. And these channels that are right here, we would integrate with your boiler and would integrate it with Kumu Cloud and tell the system at a certain temperature, hey, turn my boiler off, put my air source heat pumps on for efficiency. And you can also use it with a system that's called IFTT. That's an app. It's basically IFTT stands for if this, then that. What it does is below a certain temperature, it will tell the system to turn on, turn the system off, put my boiler on, or put my air source heat pumps off. Basically just shifting between the temperature with a weather app that is on there. So very common, least expensive of the two, I would say. I like, my personal preference is I like the if this then that. Some people like the Kumu Cloud station, but it's really preference on how you want to do it and what thermostat you want to use in your home. So let's talk a little bit about whole home energy solutions to save you money in your home and become a greener home. So let's take a look at it. Again, back to the zone comfort system. What do we do when we come out to your home? You know, what's the expectation of the contractor when they come out to your home? What is it? I mean, we're trying to design a whole home system, a comfort system for your home. And how does it happen? How do we come in and how do we do that? Well, first thing is we've got a configuration to fit to your needs. All right, so we have to look at your home, understand a home, how it goes together. A load calculation is super important, especially for heating. Manual J load calculation gets done on your home. What it basically does is it takes the outside of your home and then starts breaking it down into the rooms in your home and calculating what does this space need for heating and cooling, okay? I would not buy an air source heat pump for your home if your contractor cannot provide a manual J load calculation for your home. Please don't do that, because if you're going to know what your heating load is on your home, this is not guesswork. Please do not let a contractor do guesswork for you for heating in your home. You need to understand what kind of insulation's in your home, what kind of windows are in your home. It's one of the biggest failures I see a lot, where people buy an air source heat pump and no heat load calculation was done. They've done it based on square footage and made some basic calculations. Example is, hey, what if this house wasn't insulated at all and there was no insulation in the walls? Let's say this is a house from 1950 or 1900s, and the homeowner just had blown in insulation done in the whole home, and they just put in all brand new windows in the home, and they had the attic insulated. Well, your heat load is going to be a lot different with different types of insulation. I mean, I've seen spray foam homes with heating loads down as low as 6 to 7 BTUs per square foot. I've seen uninsulated homes as high as 30 and 40 BTUs per square foot. So you've got to know kind of what's going on in your home at that point. So let's take a look at how we would break your home down. All right, this is breaking your home down into 5 zones. I've got 5 different colors in here. If we were to look at this home, I think most contractors are going to come in and say, okay, master bedroom is 1 zone. How would I do that master bedroom? What type of system would I put in here? What would I put in the 2 bedrooms? What type of system would I put in the kitchen nook area? And what would I put in the great room area? I could go on and on. There's probably 100 different combinations of what I could put in here. And don't be surprised if you're working with multiple different contractors that you're going to probably get 5 different quotes, 5 different ways, because everyone's going to look at it differently. It's what best fits your needs, and how do you want your temperature to be controlled? I could put a ducted unit in here and put a thermostat in the hallway and have this on one zone. I could put a wall mount unit or a ducted unit in the attic here and control this space. I could do a wall mount unit in the great room. There's all different areas, but it's how do you want your home zoned, okay? So again, here's a 3-zone system with 2 single-zone systems. Maybe we might put a 3-zone in here with 1 condenser outside that does 3 zones, and maybe 2 single-zone condensers out here, or a 2-zone condenser that has 2 indoor units on it. There's a variety of different ways of what you can do for your home. But again, you've also got to look at, where do I live in my home? Maybe I don't even use this 3rd bedroom. Maybe I don't need anything in here. Maybe the backup heat would be fine in here. Maybe we don't use air conditioning in this room. So it's what best fits your needs in your area. So let's a little bit at the installation process and how the installation process gets done, because this is a key thing. Okay, I mean, when you look at Jones and you look at NETR and you look at the contractors that are coming out here, I mean, we're all Diamond Elite contractors. What's different? To be a Diamond Elite contractor, you've got to do a lot of training. You have to install X amount of systems. You have to have X amount of people trained. Look, if you're purchasing the system, you want someone who knows how to install it and also knows how to fix it in case you have a problem. All right, so very, very important when you look at that. Who is the contractor that's putting it in? All right, so let's look at the 6-step process. All right, this is based around a wall unit, but this could be a ducted unit. This could be anything. I just want to show you what happens is selecting locations, installing indoor units, installing outdoor units, interconnecting the system. I'm going to get into leak testing, charging and evacuating the lines and the refrigerant lines that would be installed, and the charging and the testing of what would need to be done. So I'm going to show you a little bit about what you'd expect in your home when someone would come in and they were going to hang an indoor unit. They'd be, this would all be talked to prior to the installation the day of with the comfort consultant, where things are going, what's going to happen. But there's that high efficiency wall unit getting hung in the wall in the house. There would be a hole that would be drilled to the outside. The holes would be sleeved and sealed on both ends, so no rodents and no cold air or anything can get into your home. You've got to be careful when people are installing things and cutting holes in your home. How are they going to be sealed? What's going to happen? Outdoor unit would get installed on a pad, on a stand, or on a wall mount bracket. You do not want this unit sitting on the ground. Please don't let anyone install that, not on a pad, on a stand or a wall bracket, typically a stand because of snow. And I know in the New York area, stands have to be at certain heights because of certain snow loads. You don't want to be out there having to shovel around your unit in the winter time, and to be able to defrost and drain properly as well. The interconnecting piping system, you can see right here of what's going on. You can see the sealant behind here. This hole would also get sealed here. And you can see this technician's using a certain wrench. It looks very big. Okay, what he's doing is there's a certain torque on these wrenches, okay, that actually tighten these nuts at a certain torque from the manufacturer. A lot of contractors just use 2 wrenches. They put them together. You have nothing but leaks. So you got to be aware of how things are being put together. Step 5 is the evacuation and the charging of what's going to happen. You're going to see a technician pressure testing things and monitoring pressure to make sure that the lines hold the pressure. You're going to also be seeing, again, here's that high efficiency unit that the gentleman hung. You can see he's doing some testing of air, some return air temperatures. You can see right here, here's that little sensor I was talking about. You can see he's measuring some temperatures in the room. So that's your 6-step process on a one-on-one system. If there was multiple systems, there would be some things going on there. So why is it important to use the right contractor when you're doing the job? I always talk a lot about this, and you've really, got to understand what can happen to your home. This is a true job that we're looking at right here. And this was a job that a customer paid a lot of money for and walked away from the job, and you can see it doesn't look pretty. So, why is it important? It's really important to know what's going to go on with your home. All right, definitely not done to code, not installed properly. Wall mount brackets with all the units on the house, this is a job we went on, the job was vibrating inside the house. I mean, you can just see it does not, I would not want that on my house. I would prefer to have something that looked like this outside with a nice concrete pad with the stands, or set on, slabs or concrete pads that you can buy from a manufacturer, or nice hard plastic pads that can be bought. But again, you can see the difference between the two. Okay, that's how a typical contractor should be doing the work. And then the proper installation techniques that would go outside. You would have some slim duct or line height on the outside of the house, and you can see it right here. You can see here's a tan house, tan line height, white line height on the side. You can actually see, if you look close enough, there is a unit sitting right here. So nice clean installation, follows the electrical lines. This was a little cottage we did up in Rockport, Massachusetts, up by the water. Here's a white house right here with some white line height on it. There was a unit in this bedroom. You can see right here, there's some white line height running down next to the electrical. And if you look close enough, there's another one right here coming out. White on white, looks nice and neat. Doesn't look like the photo that I showed you previously. I'm going to show you some case studies of some homes that have been done in the Boston area or in the New York area. Here's a cape up in Newburyport that was done. This was a convert from propane from year round. This was a 5-zone Mitsubishi system. Cost to install it was around $18,000. It was a $500 Mass Save rebate on this particular home. And this was financed through Mass Save. This was a 0% interest loan for up to 7 years. So I don't want to get into the heat loans in the seminar right now, but these are available. Comfort consultants will discuss this with you when they come out to your home to look at homes of how you can apply for these loans. Okay, you have to be not a municipal, but you have to be paying through a national grid or an N-Star in Massachusetts to get those. This is not in New York. This is in Massachusetts only. Annual savings on this was around $2,500 in their heating and air conditioning bills. This was a Jamaica Plain Colonial upgrade from an oil system. This was a 4-zone Mitsubishi system that integrated this with an IFTT thermostat. Cost to install was around $19,000. Rebate was $36.88. This was financed for 0% for 7 years. Again, annual savings was around $2,500. This is a Boston condo, again converted from an oil system, 4-zone Mitsubishi. Cost to install $21,000. Annual savings. This is a Goshen contemporary upgrade from a central AC system to 3 air source heat pumps that Jones Services did. Cost to install was around $88,000. It was a very big home, a lot of work to be done. The rebate on these in New York was $27,500. There was no financing available on this. Annual savings to the homeowner was around $5,000. And a Goshen Colonial that was updated from an oil system. This was a combo system, ductless and ducted, that was put into the home. Cost to install was around $52,000, very big system. And again, the rebate was $18,860, no financing, annual savings around $3,500. So we're going to talk a little bit about the 2022 rebates. I know everyone's trying to probably understand, hey, what's going on in Massachusetts? What's going on in New York? I can tell you what I know of today. I think we're going to see changes by next week. They're telling me by the end of January, we're going to have what's going on in Massachusetts. I can tell you what I know of today. So the sponsors of the Mass Save program have proposed it. Right now, we have the rebates for oil and electric. We are waiting on the gas rebates. We are expecting gas rebates to go up from last year. All right, we are waiting for the Department of Energy right now to say, hey, this is what they're going to be. I've been on multiple phone calls with Department of Utilities and other people in government affairs committees that I sit on, that these are coming out by the end of January. We will have them. So what do we have now, though? All right, what do we have? This is for oil and electric heated homes. All right, if you're going to do your whole home with an air source heat pump and you're going to remove the oil in your home or shut the oil burner down, it's $10,000 per home on a rebate right now. If we're going to integrate the controls and do a partial home, and we're going to do integrations, it's $1,250 per ton up to $10,000. So what does What does a ton mean? That means 12,000 BTUs. So example, if you were putting and integrating a system into your home with oil right now, and it was 2 tons, that's 24,000 BTUs. That's $2,500 in a rebate, all right? So if you have up to $10,000, I believe that's 2 4-ton units to do that. So that, you know, well, that would be about 84,000 BTUs or 88,000 BTUs of controls to put in there. If you have a home now and you wanted to add integrated controls, $500 per indoor unit, up to $1,500, okay, for the Mass Save rebates. Again, as I just said, gas should be out by the end of January, and we're expecting it to be more than it was last year. Let's talk a little bit about New York and the clean heat incentives that they have going on. So there's going to be some changes in this starting March 1st, okay? When you look at the central Hudson area, the air source heat pump partial load, okay, is at $500 today. It's going to go down to $200 March 1st. All right, the full load heating is at $1,300 per 10,000 BTUs. All right, that's going down to $500. So their rebates are declining. Massachusetts is going up. New York is going down. Their program's been in effect for longer than our program is just starting. Theirs is getting towards the ends of their programs now, but they will be releasing new ones probably in the following years. But you can see their rebates are declining now, all right? You do see contract rewards here, contractor reward, okay? So this money that the contractor award has in New York, Jones Services has said they will give back to the customers. For anyone that's sitting in this seminar today, you will get this money back in your rebate right now, all right? So if you were looking at this $500 right now, 300 of that per 10,000 BTU would go back to the contractor, but the contractor will give that back to you in this load. So again, look at Orange and Rockland County. You can see the rebates are declining as well, starting March 1st. So if anyone's on the Zoom from the New York area, you want to keep this date in mind right here, because there are going to be some pretty significant changes in the New York area. You can see full load heating with decommissioning, $2,400 per 10,000 BTUs is going down to $1,800. This has been cut in half from 10,000 BTUs. So these are all with integrated controls. Again, the gentleman and the comfort consultants that are on from Jones can answer any questions on these rebates. They're in the chat. They are willing to talk and come out to your homes as well. What does an integrated control look like? How does these work? All right. Again, this is the Kumu Cloud Station from Mitsubishi. This would be installed in your home, would be tied into a phone. That would go together with that. In Massachusetts, we have some other programs going on too. If you are a municipal electric buyer, there are programs as well. So we have to look at your town, where you are and what they are, and we can get you into the programs that we need to get you into. These are some of the different towns and some of the different offerings. They're all different. We would need to know where you live to how we would put this together for the particular rebates, but there is what's called the Muni Helps program that we are involved in. There is also from Reading Municipal Light, the Abode program is on here. There's still some rebates on that. Again, these rebates are changing daily, so we're getting information as fast as we can. These could go up, they could go down. Right now, these municipals are running on what's called the 2021 programs till the end of January. So again, this is the Abode municipal programs is where they play and what towns they're in. So again, if you sit in that particular area, that's where you would be. So we've also we've got a lot of educational ebooks on our websites. They're on Jones's. You're going to be getting an email at the end of the meeting today on these here. So everything you want to know about air source heat pumps is on here that I've written. Top questions to ask your contractors. Ductless cooling and heating, efficiency heating, cooling. Good books. I've spent a lot of time trying to give good information about these to the general public. So please, look at do do your research before you get involved in something like this. But, you know, there's a lot of information that, you know, both Jones and NETR has spent a lot of time putting together. So next steps, again, I want to thank everybody for attending. I know we've got a lot of people. We've got, you know, 70 participants on the webinar this morning. That's great. I want to thank everybody for your time. You know, please book a free consultation with one of the comfort consultants. Download our ebooks from the library. You know, all of the attendees are going to receive an email shortly. That's kind of a slide, just says MA attendees will receive an email. New York attendees, again, there is a phone number here to call, 845-789-5137. We've recorded the meeting. You will get a copy of the recording of the meeting. But, you know, Jones Services, I want to thank everyone from coming on, Matt, Tim, John, Ashley. I want to thank everybody from NETR for my help, you know, for help with the chat today. And, you know, we'll keep the chat on for another 10 minutes till 11 o'clock if anyone has any questions, and we'll go from there. Again, thank you everybody for attending and have a great day.